A concept that's really helpful in interpreting the value of the standard deviation is known as the empirical rule. This rule states that for data sets that have a distribution that is approximately bell-shaped, or shaped like the one you see right here that looks like a bell, looks nice like that with the mean piled up right in the middle, and other values that are evenly dispersed along the sides, we know that it has the following properties. We know that right about here, out one standard deviation, 68% of the data will fall in that area right there. And if we go out 2 standard deviations, we'll capture about 95% of the data. And if we go out 3 standard deviations, we will capture about 99.7% of the data. And we can use this information to help us solve real-world problems, and we can figure out where specific data values lie and about how much of the population will be captured by those data values, and how many people or data values will fall, in certain regions or areas. So let's take a look at an example and see how we can actually use the empirical rule to solve a problem. So let's see how that lets us solve a problem regarding IQ scores. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. Let's see if we can determine what percentage of IQ scores are between 70 and 130. Well, the empirical rule tells us that every time we move away from the mean of a normal distribution and we add and subtract one standard deviation, we'll capture 68% of the data. So what that means in a problem such as the one that we're looking at, we can add and subtract a standard deviation in order to capture 68% of the data. So in this problem, we have a standard deviation of 15. So every time we move out, we're going to add a 15 on this side and subtract a 15 on this side. So at one standard deviation, I'm going to add 15 and subtract 15. Down here, at 2 standard deviations, I'm going to add 30, because 2 times 15 is 30, and I'm going to subtract 30. When I get to 3 standard deviations, I'm going to add 45, because 3 times 15 is 45. And over here, I'm going to subtract 45 from the mean. So let's see how that works to add it in and see how we can calculate how many are encompassed by 70 and 130. So when I'm working problems like this, I find the best thing to do is label everything I know. We know that the mean is 100. Oh, I don't mean to have such a large writing utensil there. Let's see if we can't get something a little smaller. The mean is 100 and the standard deviation is 15. Let's write this on our curve. Let's put the mean in the middle because that's where it always is on a normal distribution, the mean of 100. Now, we know that we're going to add and subtract standard deviations in our units of 1, 2, and 3 on either side. We're going to add and subtract that to our mean. So our mean is 100. On the right, we're going to add it because we're going in the positive direction. So let's add 1 standard deviation in the positive direction. So 100 plus 1 standard deviation gives us 115. Let's add 2 standard deviations on the next step. So 2 standard deviations was 30. So we're going to have 130. Notice how we're just adding a standard deviation each time we move out. So now we're going to add another standard deviation, and we have 145. So see, we're just adding a standard deviation every time we go. We're just adding 15. And we're adding 15 more. And 15 more. So it's really 15, and then 2 times 15, and then 3 times 15. So now we're going to go to the other side, which is the negative side, and we're going to subtract 15. So if we subtract a standard deviation, we're going to subtract 15 from 100, and we're going to have 85. So 1 standard deviation away from the mean on the left is 85. 2 standard deviations away from the mean on the left would be 70. We would subtract 30. Let's subtract 15 again, or 3 standard deviations, which would be 45, and that's going to take us down to 55. So now that we've filled this in, we didn't really need to fill the whole thing in just to answer this one question, but it sure does make it a lot easier to have all this information in case we need to answer more than one question. Let's answer the question that we were asked. What percentage of IQ scores are between 70 and 130? Well, we want to know how many are between 70 and 130. Well, the empirical rule tells us that 95% of the data is between 2 standard deviations, and we just calculated that 2 standard deviations hold 95% of the data. So now we know 70 and 130 encompass 95% of the data. Now, back on the first screen, I gave you a chart that told us all the breakdowns of percentages in these extra sections here. So let's say you were asked what percentage of data was encompassed between the IQ scores of, let's say, 85 and 145. Let's just say you were asked that. You could figure that out too, even though that's not a nice, neat one that's just one of the 68, 95, or 99.7, because you know these values that are right in here. You know that in here is 34%. You know that because I gave you the chart that it's on. And we know that right here is 34%. Notice how that adds up to 68%. We know that right here is 13.5%. And we know this little itty bitty part right here is 2.35%. If we add all of that up, because this is what we want to know from 85 to 145. If we add all of these up right here, these are the percentages that take up from 85 to 145, we will get 83.85%. So the percentage of IQ scores that would be between 85 and 145 would be 83.85%. So that's how we can use the empirical rule to solve percentage problems. It's really quite easy. I find it the easiest to just draw my empirical rule, label all of my standard deviations, because it's really simple just to add all 3 down the right and subtract all 3 down the left, and then start solving my problems. So, I hope this helps you solve your homework problems.